Hello guys, welcome back to my channel. In this video we are going to see about parsers. As we know, parsers are actually one of the most important topics of compiler design. We have already seen the various phases of compilers, right? So generating the parsing table is one of the most important phase or most important task that a compiler is performing. So, and again, if we talk in terms of syllabus also, in any our academic syllabus like BTech, MTech, or in terms of any competitive exams like GATE, PSUs, or any exams you can talk of, parsers is actually one of the most important topics for these exams also. If we talk about particularly about GATE, then out of 4 or 5 marks of compiler design, you can expect that there is almost any one question that is present which is directly or indirectly asked about parser. So it is, yes, a very important topic. So in this video we are going to see an overview of parsers, the main types of parsers, because directly any 1 mark question can also be asked about the types of parsers, and in our further videos we will see each of the parsers or the important parsers in detail also with the examples, right? So in this video let us see the main types of parsers, how they are categorized. First of all, our parsers can mainly be categorized into two parts, that is top down parser and bottom up parser. Fine, as the name itself indicates, top down parser will parse our string from top to bottom, and bottom up parser will parse the string from bottom to top. Fine. Now if we talk about top down parsers particularly, top down parsers can again be categorized into two parts, that is top down parser with full backtracking and top down parser without backtracking. Now what do we mean by backtracking? Whenever our parsing is done randomly, like we are having many options, we are tracking in one sequence, then we find out that there is something wrong, we backtrack or we kind of undo or reverse the whole thing, and we are starting all over again. If there is any problem, we are again backtracking or reversing the whole thing, and then we are starting all over again. This process is known as backtracking. So obviously backtracking is something that is overhead, means we don't want our compiler to backtrack again and again, or we don't want our parser to backtrack again and again. So top down parsers with full backtracking, this is one outdated method. We are not generally using it in our today's day-to-day life. Fine. But still, yes, it is a type of top down parser, that is top down parser with full backtracking. And the example of this is brute force method. As we know, what is brute force method? In various security measures also we have seen about this brute force method. It is nothing but brute force method means what? In this method, we are not going in any particular system wise or process wise. In this, what we are doing, we are randomly doing what? Try and error. Right, we are randomly taking the numbers, we are randomly taking the path, and we are doing try and error. If one procedure fails, we are going with the other one. If another one procedure fails, we are going with the some other procedure. So this is actually a trial and error method. But as I told, this top down parsing with full backtracking or brute force method is not generally or practically used, because obviously we don't want overhead, right? That our parser will spend most of its time in backtracking or in trying the things and coming back, trying another thing and coming back. Obviously we don't want that. So this brute force method is something that is not generally used in our day-to-day parsing. Then if we go about in the second part, top down parser's second category is top down parser without backtracking. Obviously one was full backtracking, so this is without backtracking. And top down parsing without backtracking is categorized into two parts, that is recursive descent parser and non-recursive descent parser. Now in recursive descent parser, when we study about this recursive descent parser, what happens in this, let me give you an overview. In this we are having separate methods for all the variables. For example, we are having any grammar like if I am having any grammar like E gives E plus T, then T gives ID. Let me take it simply like this: E gives E plus T and T gives ID. If I am having something like this, what happens that which are the variables? Variables means what? non-terminals. So which are the variables or non-terminals here? Capital E, capital T, these are variables. So in this, what happens in this recursive descent parser, that we will make separate table, we will make separate function for all the variables. That is, one function will be there for E, one function will be there for T. First of all, starting, so how the whole procedure works, that first of all the starting symbol, the function of the starting symbol will be called, because we know that the whole process starts with the starting symbol. So first of all, the process here, the starting symbol is capital E. So first of all the procedure of capital E will be called, and from that E, again this E will be called, and then this capital T function will be called, and like that the procedure goes on. We are having function for match, we are having look ahead variable. So when you will study this in detail, you will get to know all the terms. But basically what happens in this recursive descent parser is, we are making, simply you can remember this, that we are making procedures or functions individually for all the variables that is present in our grammar in this recursive descent parser. Fine. Now the second part or the second type is non-recursive descent parser. This non-recursive descent parser is one of the important parsers. It is also known as LL1 table, LL1 parser. Fine. This LL1 parser is, you can say that, one of the most important parser of this top-down parsers. Among these all top-down parsers, this LL1 is one of the most important. Many questions are being asked on this LL1 parsing table, and when we will, in this, how the parsing is done with the help of LL1 parsing table. Now in our further videos we will see about this LL1 parser in very detail. We will see the example, how to solve the example of this, how to check whether a grammar is LL1 or not. We will see all the things in detail. Fine. Then we are having bottom-up parsers. In bottom-up parser, they can be categorized basically into two parts, that is operator precedence parser and LR parsers. Now first of all, what is operator precedence parser? It is one of the type of bottom-up parser. Now this operator precedence parser, the most important thing you can remember about this is, or it is actually a frequently asked question, that operator precedence parser is the only parser among all these parsers. Fine. Among all these parsers, operator precedence parser is the only parser that can parse ambiguous grammar. So its specialty is what? Why it is very famous? Because it can parse ambiguous grammar. All the other parsers that we have talked about, none of the parsers can parse any ambiguous grammar. But this operator precedence parser is the only parser that can parse the ambiguous grammar. Now we are having certain rules about this operator precedence parser, that we cannot have null on any of one of the side, we cannot have variable and terminal together, and like this we are having certain rules in terms of this operator precedence parser that we have to take care about. We will see those things in the specific video that we will see about this parser. Fine. Then we are having LR parsers. Now in this bottom up parsers, LR parsers are most important. Fine. We will see these LR parsers. In LR parsers we are having four types, that is LR0, SLR1, LLR1 and CLR1. These LR parsers, all these four LR parsers are very important. We will see all these parsers in very detail with multiple examples, because it is very important for you to clearly identify the differences between these parsers, how they work, how they are parsing the string. Doing this, what is this? See, in bracket we are having 0, 1. What are these? These are actually about the canonical items. So what are the canonical items? What are look aheads? How to parse the table? What is the difference between the parsing table of all these four parsers? So all those things are very important. So basically in this video I wanted you to note down this whole graph about the parsers, because obviously before going in detail into the parsers, into each of the parsers, it is very important that just you get the introduction of all these. Which parser comes in which category, what is the specialty of which parser. Like I told, this LL1 parser and these LR parsers are most important. So it was important to at least come across the names of all these parsers, the categories of all these parsers. Then as I told, in the coming videos we will see each of the parser in detail. So yes, for now just see this categories very carefully, you can note them down, and then eventually in the next videos we will see them in detail. Okay, thank you.